Okay, picking up with the next problem, find y double prime. Again, let's do a little rewriting here. That's cotangent 1/4 x. And let's do a little recall. You can do the chain rule on this, or we could just recall that when you have a linear argument, mx plus b, and even if the plus b was there, the derivative of cotangent mx is going to be negative m cosecant squared mx. That the effect of that slope, when you have a linear argument, linear angle, and even if it is mx plus b, the effect of the slope from the chain rule is to multiply by it. Now, if you want to do an explicit chain rule each time and show it, that is fine. But the slopes here are going to creep up so often that, try to get a little level of sophistication and just remember that the effect of that m is going to be multiplied by it from the chain rule. So using that, pretty quickly, my first derivative, because the only way you can get to the second derivative is to go through the first derivative, my first derivative is going to be negative 1/4 cosecant squared 1/4 x, which is the same as negative 1/4 cosecant 1/4 x quantity squared. Again, emphasizing what that notation means. Cosecant squared written that way with the square right by the cosecant is the same thing as the cosecant of 1/4 x quantity squared. So now when we go on to the second derivative, I have an inside function of the cosecant 1/4 x, an outside function of that exponent of 2. So my second derivative, that 1/4 is just a coefficient. Do not need a product rule. Just write it down. This is what we see right there. Then start with my outside. Multiply by the exponent. Leave the inside alone. Decrease the exponent by 1. Derivative outside. Plug in plain inside. Then the rest of the chain rule times the derivative of the inside. So let's finish it up. Let's do a little recall here. The derivative of cosecant mx. Again, the effect of that m from the chain rule is going to be to multiply. So I'm going to get negative m, and then the derivative of cosecant is going to give me cosecant mx, cotangent mx. So this will become, can we write it small enough to get it there? Negative 1/2 cosecant 1/4 x, and I certainly don't need that exponent of 1. Then doing my derivative on the end, the effect of that 1/4 will be to multiply by it. So cosecant 1/4 x, the rule we're using, cosecant mx, derivative of cosecant mx is negative, and I forgot the negative sign there. So let's put the negative in there. Negative 1/4 m, and then cosecant 1/4 x, cotangent 1/4 x. And then making this look pretty, I've got 1/8, negative, no, 1/8, negative 1/2 times negative 1/4, 1/8. And then here I do have cosecant 1/4 x times cosecant 1/4 x. For cosecant squared 1/4 x, cotangent 1/4 x. And there's my second derivative. Okay, So this somewhat alluded to what we're moving to next. There were multiple rules kind of involved in this problem, but it wasn't too bad. Now we're going to move on to slightly harder problems where there are multiple rules involved. And so that's the headline that we have here, mixed rule derivatives. So differentiate this guy. I'm going to zoom in just a little bit. So when I look at this, I have x squared plus 4 cubed and 3x minus 5 quantity to the 7th. That this is a product to begin with. That there's my first factor and there's my second factor, and so we are going to use the product rule first. I'm choosing the product rule first because I can describe the entire problem as this times this. There's a first factor and there's a second factor. And so since I can describe the entire problem by saying first times second, I start with the product rule. So go think back to the product rule. Plane first. Plane first, derivative of the second, horrible handwriting, derivative of the second plus plane second, derivative of the first. Product rule. Plane first, derivative second, plane second, derivative first. So plane first, not going to do anything. Just write it down again. But derivative of the second, here it's going to be a chain rule. Inside, 3x minus 5. Outside, exponent 7. EXP stands for exponent. Exponent 7. So I switch to the chain rule now. So I'm going along my merry way with the product rule. Plane first, then I get to derivative of the second, I switch to a chain rule. So I start with that. Multiply by that, start on the outside, multiply by the exponent, leave the inside alone, then times the derivative of the inside. So here we have derivative outside, derivative out, derivative in. Chain rule. I'm up to the plus sign, plane inside, leave it alone. Then I get to that last derivative. It's another chain rule. Inside, x squared plus 4. Outside, exponent of 3. So I switch to the chain rule again. Start on the outside, multiply by that exponent. Leave the inside completely alone. Decrease the exponent by 1. Then times the derivative of the inside. Derivative outside. Derivative inside. And all of that was the chain rule. So then we're going to keep going on it. I'm going to move that 7 to the front. And so I have x squared plus 4 quantity cubed, 3x minus 5 to the 6. Then that last derivative I need to do, the derivative of the inside, times 3. So that's the derivative of the inside right there. Then I'm up to that plus sign, so 3x minus 5 to the 7th. And I'm going to move that 3 to the front again, too, because it looks prettier there. So just moving that 3 to the front. And then x squared plus 4, quantity squared. Then my derivative of the inside, that derivative on the end, the derivative of x squared plus 4, 2x. And so that's where that 2x came from. Okay, simplifying. And we do want this thing simplified. Some easy steps first. 3 times 7, 21. So I've got 21, x squared plus 4, quantity cubed, 3x minus 5 to the 6th. And 3 times 2, 6, and I'll bring that x up front. And I'm just going to reorder a little bit. And then this factors some more, or this simplifies some more by factoring. There's all sorts of factoring we can do here. 21 and 6, both divisible by 3. X squared plus 4 cubed, x squared plus 4 quantity squared. I could take out an x squared plus 4 quantity squared. Take out the smallest number from both of them. And the same thing here, 3x minus 5 to the 6th, 3x minus 5 to the 7th. I can factor out a 3x minus 5 to the 6th. But this is going to simplify by factoring. So I decide what's common to both terms, and then factor. 21 divided by 3 is 7. I had x squared plus 4 cubed, took out x squared plus 4 squared, so there's one factor of that left. Had 3x minus 5 to the 6th, took out 3x minus 5 to the 6th. Let's write that so it's legible, I guess. Up to the plus sign. Had 6, factored out 3. 6 divided by 3 is 2. Didn't do anything with the x. Had x squared plus 4 quantity squared. Took out x squared plus 4 quantity squared. Had 3x minus 5 to the 7th. Took out 3x minus 5 to the 6th. So there's one factor left over. And we are almost done here. I can now distribute. For 7x squared plus 28 plus 6x squared minus 10x. And then finally, and we'll just barely get it on the page here, 3x squared plus 4 quantity squared, 3x minus 5 to the 6th, then 13x squared minus 10x plus 28. And there's my simplified derivative. And honestly, I do expect that because it is just factoring. Okay, and we'll conclude that video.